Good morning. Today I am going to be filming module 2.5, still under unit 2, module 2. And again, our unit is equations in one variable. And module 2.5 is solving equations involving absolute value. So look at our learning target. I can solve absolute value expressions. So let's quickly refresh our memory as to what is absolute value. And absolute value is nothing but the distance of a number from 0 on the number line. So as we've done before, we can have two numbers which are the same distance from 0 on the number line. One will be to the right of 0 on the number line, and one will be to the left of 0 on the number line. So if I think of 2, how far is 2 from 0 on the number line? It's 2 units. But I also have negative 2, which is also 2 units from 0 on the number line. And please remember, distance cannot be negative. Okay, so obviously when we are saying how far is negative 2 from 0 or how far is 2 from 0, it would be 2 units. So distance is a positive thing. Okay, so the simplest form of writing absolute value is this over here. Okay, so you know that absolute value is shown by the two longer lines, and that signifies that this is absolute value and is equal to n, and that's what this means. Okay, so that is absolute value. So again, absolute value equations contain at least one absolute value expression, and the simplest form of an absolute value equation is absolute value of x is equal to n. And because absolute value represents distance, you must consider the case where the solution of x units from 0 in the negative direction and the case where the solution is x units from 0 in the positive direction. So as I said, distance is a positive thing. So we've got to look at both sides of 0 on the number line. Okay, so now when we are solving equations that involve absolute values, there are two cases that we have got to consider. Okay, so when I'm solving these, and the expression inside the absolute value symbol is positive or 0, and that's the first case. And the second case is the expression inside the absolute value symbol is negative. So that means I can have, as I said earlier, we can have 2. We can also have negative 2. All right, so these are the two cases that we can have inside the absolute value symbol. All right, now let's say we consider an equation where we say that I have absolute value of x is equal to 3. Let's say I have something like this. And this means that the 2 points on the number line where the distance between 0 and x is 3 are solutions to the equation. So if I draw a number line really quick, and I have 0, 1, 2, 3, negative 1, negative 2, negative 3. If I have this, and so let's look, if I have from 0, so if I have 3 here, and I have negative 3 here, and I am looking at this distance, and then I'm looking at this distance. So if I look at this distance, how much is this? This is 3 units. Okay, so negative 3 is 3 units away from 0. And the same thing, positive 3 is also 3 units from 0 on the number line. Okay, so therefore we have, these are my solutions. And the distance between 0 and negative 3 is 3. So negative 3 is a solution to the equation, and 3 is also a solution to this equation. And if I was graphing it, this is how I would graph it. So we are looking from 0 all the way here and all the way there. And that's basically what absolute value means. So again, if I'm looking at this, what are my two solutions? So I can have x can be what? X can be 3, but x can also be negative 3, right? So the solution set of this is going to be, I'm going to write a set like this. Set is written in this format. Okay, the solution set in this, we have negative 3 and we have 3. Consider both the cases for each absolute value equation. And to solve an absolute value equation, first isolate the absolute value on one side of the equal sign if it is not already by itself. All right, so let's go ahead and solve. There are two problems I have put on the board. One is when n is greater than 0. Okay, so is equal to n. So when n is greater than 0, and we're going to look at another one where n is less than 0. Okay, so let's do this first problem where when n is greater than 0. We are going to solve this and then we are going to graph. All right, so if I look at this, we can have two scenarios here. Okay, we can have case 1. Okay, we are going to have case 1 and we are going to have case 2. There are two cases that are possible with this. So in the first case, when absolute value of y is y. So that is my first case. And then my second case is, so in the first case, what is this? This is non-negative. Okay, so when y is non-negative, that is my first case. And in the second case, y is negative. So over here, y is non-negative. Over here, y is negative. Because both of them, see, as we said, we can have two of the scenarios. So in this case, what are we saying? Then absolute value of y is going to be negative y. So I can have two of these cases. So let's solve the first one where I am saying that y is non-negative. So I'm going to take the original equation, all right? And then I am going to do this. Absolute value of y plus 2 is y plus 2. I'm going to write it out. Okay, is equal to 4. Is equal to 4. And then I am going to use the subtraction property of equality and subtract 2 from both sides of the equation because I am trying to solve for y. Okay, so minus 2, and so y is equal to, what is 4 minus 2? I get 2. So when I simplify, this is case 1. Now let's look at case 2. All right, so in this, it's going to be y plus 2 is equal to what? It's going to be my negative 4. So it can be 4, it can also be negative 4. All right, so negative 4. And then when I solve it, again, I'm going to use the subtraction property of equality, and I'm going to subtract both sides, negative 2 from both sides, or minus 2, because the inverse of addition is subtraction. And so I'm left with y is equal to, if I have negative 4 and I have negative 2, I end up with negative 6. So here is my other scenario that I can get when I simplify. So what is my solution set? I have negative 6 and I have 2. So here is my solution set. Negative 6 and 2 are solutions for this. This is my solution set. Okay? Here, I'm just going to write it down so you can see what it's called. It's called the solution set. And please remember, the set is written within these curly braces. Okay? Now, if I'm going to graph this on the number line, I make a number line. And a solution set has -6 and 2. So I can say 2, 1, 0, -1, -2, -3, -4, -5, and -6. Okay, and if I am graphing it over here, let me use a different color so you can see. And my graph, I have, what are my solutions? Y is equal to -6. Here's 1, and y is equal to 2. So here are my solutions over there graphed out. So we are going to graph points at -6 and 2 on the number line. Okay? Now, if I am checking my work, it's always important to check. So I'm going to take my original equation and then I am going to substitute the values into it. Okay? So for the one where I am saying this, where y is equal to -6, all I do is I take the -6 and I substitute it into the original equation. And what is y plus 2? So instead of y, I'm going to put -6. What is -6 plus 2? I get -4, so that is correct. In this one, it says y is equal to 2. So instead of y, what am I going to do? I'm going to put 2. And what is 2 plus 2? I get 4. So yes, I can see that the equation is true. So to check my work, I just substitute the value for y that I have in the solutions set, and then I check whether my equation is true or not. All right? Now, let's do a problem where it is saying that this one, for example, okay, when n is less than 0. So this is my n. Now, let's look at this one. It's saying absolute value of 3x minus 1 is equal to -1. Means that the distance between 3x and 4 is -1. Can distance be negative? Distance cannot be negative. So because distance cannot be negative, if I'm looking at this one, I know that this is going to be an empty set. It's an empty set. So I'm going to write it like this. All right? And what does this mean? This means it's an empty set. And why did we get this response? Once again, because distance cannot be negative, so the solution set is an empty set. Okay, the solution set is an empty set. Once again, distance cannot be negative. Okay, so let's go ahead and I am going to take you to the whiteboard for a second, and we are going to look at this as to which statement is true. For the solution of ax plus b is equal to c to be an empty set. So if I'm looking at an empty set, I know that if I'm looking at this part and I'm looking at this part, the c cannot be negative because distance cannot be negative. So let's look at this. If it's saying, the first one is saying, if a is negative, then the solution will be an empty set. Okay? No, because it is okay for a to be negative, because within the absolute value, I'm going to have to do the calculations, and it doesn't matter if it's negative or positive, okay, within the absolute value symbol. If b is negative, solution will be an empty set. No. this can be positive or negative. All right. If C is negative, the solution will be an empty set. Now, that is correct. This one is correct because distance over here cannot be negative. So that's why C cannot be negative. And the last one is saying if C is positive, the solution will be an empty set. No, distance is a positive thing. Distance cannot be negative. So D is correct. So the only one which is going to make this statement true for it to be an empty set is where my C is going to be negative, and so that is answer choice C. If C is negative, the solution will be an empty set. Okay? All right. So let's go ahead and we are going to solve a problem for an absolute value equation. Okay? So this is telling me that if I look at music, all right, depending on the size of each song, Luna's phone holds an average of 2,000 songs, give or take 250 songs. Write and solve an equation involving absolute value to find the maximum and minimum number of songs that Luna's phone can hold. So it's giving you your music library is at full capacity with 2,000 songs. All right. So the maximum and minimum number of songs will differ from the average by 250 songs. So we are going to go ahead and write out an expression for this, or an equation, sorry, not expression. We're going to write an equation that represents the maximum and minimum number of songs. So the difference between the number of songs and 2,000 is 250. So let's say X is the number of songs. Okay, so X is the number of songs. And it's telling us that the number of songs is X, and so it's saying the difference between the number of songs and 2,000. So number of songs and 2,000, okay, is equal to 250, is equal to 250. So there is my equation. So think of the equation I've just written, and I am going to take this and I'm going to put both the scenarios, case 1 and case 2, on the board so you can see how to solve this. And we just said X minus 2,000, absolute value of X minus 2,000 is equal to 250, right? I said absolute value of X minus 2,000 is equal to 250. And this is what I just concluded based on that question that was provided to me. Okay, now I am going to do both the cases. So let me look at both the cases. So case 1 and we have case 2. We have case 1 and we have case 2. All right, so case 1 is where it is non-negative. So X minus 2,000 is equal to 250. And case 2 is where it is negative. So X minus 2,000 is equal to negative 250. So those are the two cases that I can have. A non-negative and I can have a negative. And then we are just going to go ahead and solve it. So we are adding 2,000. We are adding 2,000 to both sides of the equation. And same thing over here. Okay, we are adding 2,000 to both sides of the equation. All right, so 2,000 minus 2,000. And then if I have 250 plus 2,000, X is equal to What do I get? I get 2000 plus 250. I get 2250. Okay? And over here I get x is equal to, it is negative 250 plus 2000. That's like saying 2000 minus 250, and I get 1750. So what is my solution set for this? My solution set is going to be 1750, and I am going to get 2250. So this is my solution set for this problem. And the maximum and the minimum number of songs are 2250 and 1750 respectively. Okay, so now what we are going to do is we are going to write an equation involving absolute value for the graph. So for this, I'm going to take you back to my whiteboard. So we are finding an equation involving absolute value for the graph. So first thing what I need to do is I need to look at the 2 points that are plotted. So we're going to write an equation involving absolute value for the graph. So the first thing that I would suggest is look at the points that are plotted. I have 17 and I have 27. Okay, so what I would suggest is take 27 and subtract 17. And what do I have? I have 10. That is the distance from there, right? From 27 to 17, I have 10 units. So then I look at what is half of 10, okay? So divided by 2, and I get 5 units, right? This is division. Okay, so 10 divided by 2, I get 5 units. So I'm going to go from 17, 1, 2, 3, 4, 5. So here is my 5 units. And which is at what point? Which is at 22. So this is my, where it's half of 10. So that is 5 units. So guess what? From this point, 17 is how much? It's 5 units, right? And then also, if I look on this side, from here 22 to 27, I also have 5 units. So this is the thing that I need to look at. Now, once I have this, the equation that I can do, okay, is the absolute value of x minus, what is this point? This is 22, right? So x minus 22 is equal to 5. Is equal to 5. So I just wrote out that equation because we know that the midpoint between 17 and 27 is going to be 22. All right, so this is how you write out an equation. All right, let's do one last one where the midpoints are so you understand what I am doing. So here's one. And we are going to label each graph with the correct absolute value equation. Okay, so we're going to label each graph with the correct equation. And my equations are written on the top. Okay, so let's look at the first one. And I have this distance. This is my distance. Okay, so if I look from -2 to 4, I know that my distance is how much? It is 6. All right. So what is half of 6? Half of 6 is 3. So I'm going to go 1, 2, 3. Because this is 3 units here. And from here we have 3 units on the right. And what number is that midpoint? That midpoint is 1. Right? So in this case, what is my equation? So it's going to be absolute value of x minus the midpoint, which is 1. And what is my distance that I'm getting? I am getting 3. So that is my first equation. Okay? let's look at, so this one is here. Let's look at my second graph. Okay, so I'm going from -2 all the way to 8. And so absolute value of 8, absolute value of -2, I add 8 plus 2, what do I get? I get 10. So my midpoint is going to be 5 units away, right? So 1, 2, 3, 4, 5. This is my midpoint, okay? Because from here I have 5 units and from here I have 5 units. Does that make sense? Okay, so now when I look at this, my midpoint is how much? Is 3. So this is what I'm looking at when I am subtracting. Okay, so in this case, what do I have? I have absolute value of x minus the midpoint, which is 3. And what is the distance that I get? It is 5. All right, now let's look at the next one. And in the next one, it's going from -5 all the way to 7. Okay, so if I'm going from -5 to 7, so that means 7, and so we have the absolute value of 7 plus we have the absolute value of -5. So what is that total amount? This total distance is 12. Right? So if it's 12, let's look at what is the midpoint. Okay, so 1, 2, 3, 4, 5, 6. Because half of 12 is what? It is 6. So I have 6 units this side and I have 6 units this side and my midpoint is 1. So if I'm writing out an equation, I would write absolute value of x minus 1 is equal to, what is my distance? It is 6. All right, now let's look at the last one. And the last one is going from -9 to 3. So we have once again absolute value of -9 plus absolute value of 3. So what is 9 plus 3? I get 12. So what is half of 12? Is 6. So it'll be 6 on the other side, 6 on this side. Right? So I'm going to go 1, 2, 3, 4, 5, 6. All right? And what is this? This is going to be -3. Right? And so we have 6 units here and we have 6 units over here. So my midpoint is how much? It is -3. So let's do this. And we have absolute value of x minus -3 is equal to, what is my distance? Is 6. So when I remove negativity, what happens? It becomes positive, right? So x minus -3 is going to become absolute value of x plus 3 is equal to 6. So the fourth one is x plus 3 is equal to 6. And that's how we label each graph with the correct equation. All right, and so this is the lesson on absolute value. Once again, please remember that there are 2 solutions in the absolute value set because absolute value is nothing but the distance of a number from 0 on the number line. And so if the absolute value of a number is 8, I can have 2 solution sets. It can be 8, it can be -8. Because both are the same distance from 0 on the number line. And then of course, if we are given any equation, we are going to solve for the variable by isolating the variable, and there are 2 cases that are possible, which would be positive and a negative one in order to form the solution set. And please remember, distance cannot be negative, otherwise that will be an empty set. All right, guys, have a fantastic day, everyone.